Hello and welcome back to section 2 of chapter 9. So here you can see that we have a table of exact values for increments of pi over 6, pi over 4, and pi over 3. Now realistically, what I do is I try to understand or know the sine and the cosine values, and then everything else is just a derivative of. So a couple quick things to point out. Notice anytime we have an increment of pi over 4, sine and cosine are the exact same. And that's because if you look at the first, and really any quadrant, pi over 4 is really 45 degrees. If you look at that first quadrant, so that splits that first quadrant up into two equivalent angles or 45-degree angles. So your x and y values at that point are going to be the same. The next thing we've got here is we have our I like to go in x and y terms actually. So for pi over 6, your x value is actually going to be the square root of 3 over 2, and your y value is going to be 1/2. And then when you get up to your pi over 3, your x value is going to be 1/2, and your y value is going to be the square root of 3 over 2. Now in class, I kind of showed you a little trick for helping you remember those. If you don't remember, I'll help you when I'm back. But I really just kind of focus on these because if I know my sine and my cosine values for these three here, then everything else is just a derivative of. Because remember, tangent, and let's just do the tangent of pi over 6. Well, this is really your y divided by your x, or your sine value divided by your cosine value. So if you know that your sine value at pi over 6 is 1/2, I'm really going to take that 1/2 and divide it by the square root of 3 over 2. So if I keep the 1/2, change division to multiplication, and flip that square root of 3 over 2, my 2's are going to cancel, and I'm left with 1 divided by the square root of 3. And way back when we talked about rationalizing, okay, I can't have a radical in the denominator, so I multiply the numerator and the denominator by that radical, or in this case, the square root of 3 over the square root of 3. And what that gets me is 1 times the square root of 3, which is the square root of 3. And then in the denominator, I have square root of 3 times the square root of 3, which is 3. So the tangent of pi over 6 is really equal to the square root of 3 over 3. Now, with a cotangent, I know the cotangent is really the reciprocal of that. So, and honestly, I would probably go back to this step right here. So the cotangent of pi over 6 is going to be the reciprocal of 1 divided by the square root of 3, or the square root of 3. Okay, and then secant, remember secant is really 1 over the cosine. And cosecant is really 1 over the the sine value. So you can just reciprocate sine and cosine, and that's how you come up with your secant and cosecant. So I only try to remember the sine and the cosine, knowing that everything else is a derivative of. So here's just a quick picture of the unit circle of all your x's, remember, are cosines. All the way around the unit circle, and your sine values are all of the y's. You can see that we have in the blue letter or numbers and stuff on the inside here, these are all your radian measures. So for our next example, it says use the figure in the previous slide, which was that unit circle, to find each value. So whenever I have to do a trig function, I kind of sketch it out because I want to know like which quadrant I'm in. So 5 pi over 6, I know that when I get over here to pi, that's going to be 6 pi over 6. So 5 pi over 6 is really going to be sitting here in quadrant 2. Any increment of pi over 6 is going to have a coordinate point of the square root of 3 over 2 and 1/2. Now, because I am in the second quadrant, that means my x values are really negative. Now I'm taking the sine of 5 pi over 6. Well, sine is really my y value, so I know that the sine of 5 pi over 6 then is really equal to a positive 1/2. And that would be my final answer. So for this part, we have the cosine of 2 pi over 3. And as I've mentioned before, I'm going to sketch this out. 2 pi over 3 is actually in the second quadrant as well. I know that when I have denominators or some increments of pi over 3, I know that my coordinate point is going to be a 1/2 and the square root of 3 over 2. Now, because I'm in the second quadrant, I also know that my x value is negative. So cosine is an x value. So that means that my cosine of 2 pi over 3 is really equal to a negative 1/2. Now for part C, I have to find the tangent of 4 pi over 3. So again, I'm going to sketch. And if I look at my unit circle, pi is really 3 pi over 3. So 4 pi over 3 is really going to occur down in that bottom quadrant. Well, whenever I'm looking at pi's over 3's, I know that I'm going to have coordinate points dealing with x values of 1/2 and y values, which are the square root of 3 over 2. The tangent is really equal to y divided by x. So I'm going to end up with the square root of 3 over 2 divided by 1/2. Now, before I go any farther, in this third quadrant here, I know that both my x and my y are negative. So you can go ahead and throw on a negative. Now, when I divide a negative by a negative, that does give me a positive tangent value. So I'm going to keep my square root of 3 over 2, change my division to multiplication, and flip that fraction of 1/2 and make that 2 over 1. I can see my 2's are going to cancel, and I'm going to be left with a positive square root of 3. And that would be my tangent for 4 pi over 3. Now for part D, this one's almost like a trick question because it wants us to find the tangent of a negative 2 pi over 3. Well, remember with negative values, we actually have to go clockwise. So that means that at pi, I would have, if I went a full revolution around in the clockwise, or sorry, a half a revolution in the clockwise direction, that would take me to pi. Well, pi is 3 pi over 3. So because I had a negative 2 pi over 3, a negative 2 pi over 3 is really going to fall in that third quadrant. Okay, and again, I'm dealing with the denominator of 3, so that tells me that my coordinate point is going to be a 1/2 and a square root of 3 over 2. Third quadrant tells me both of those are negative. And again, I'm dealing with a tangent. And the tangent of a negative 2 pi over 3 is really going to give me my y value, or a negative square root of 3 over 2, divided by a negative 1/2. And we just simplified this in the previous problem. So we can see that that's also going to give us a positive square root of 3. Now for part E, which is our final part for this example, we actually are going to take the secant. But I still want to know where the pi over 3 occurs. So pi over 3 is actually in the first quadrant. So, and because it is a pi over 3, I know that I'm going to have 1/2 and a square root of 3 over 2 for my x and y. Both of them happen to be positive because we are in that first quadrant. And secant is really equal to 1 over the cosine of pi over 3. So really, I end up with 1 over cosine is my x value. So I end up with 1 over 1/2, which gives me 2. So the secant of pi over 3 is going to give me a positive 2. And for our final part, we have the secant of a negative 5 pi over 3. So I'm going to sketch this out. So I have 1 pi over 3, 2 pi over 3, 3 pi over 3 is at pi, 4 pi over 3 is in the second quadrant, and 5 pi over 3 is in the first, because again, I'm starting out here at the point 1, 0. I'm going in the clockwise direction, and I'm going to end up with a negative 5 pi over 3, which is really the same thing as pi over 3. So my coordinate point for an increment of pi over 3 is 1/2, and the square root of 3 over 2. Both x and y are positive in that first quadrant. Secant is really equal to 1 over the cosine. So 1 over the cosine then is really going to give me 1 over 1/2, which is really going to give me 2. This is going to conclude section 9.2. Please let me know if you have any questions. Otherwise, I hope you guys have a great day, and I will see you guys next week.